Okay, on worksheet for section 6.5 and 6.6, you asked for question 8 and question 12. Remember that on question 8, we've got sine of x, and we can go back to our unit circle, and the sine of 0 degrees is 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is -1, and sine of 2 pi is 0. So this has a nice sinusoidal curve. Now we've got a change here in that we're negating the angle as well as the function. Recall that a negative inside the function gives us a translation, or a reflection I should say, about the y-axis, and a negative out in front gives us a reflection about the x-axis. So we're reflecting about both. But if I can't remember how to do that, so the reflection about the x, this point would now be over here, this point would now be over here, and here we were down, so now we're going to be over. It's just total reflection, but then a reflection about the x as well is going to change these. Well, let's go ahead and just pick some values and plug them in. If we've got 0 degrees, or 0 radians I should say, -0 is 0. The sine of 0 is 0. Make that negative is still 0. Pi over 2. If we look at negative pi over 2, well, that's the same as 3 pi over 2. The sine of 3 pi over 2 is -1. And then we're going to make that negative, so now it's going to be up here positive. I'm sorry, we were looking at pi over 2, not 3 pi over 2 at the time. If we look at pi, if we make negative pi is the same as pi, so the sine of negative pi would also be 0. Make that negative and we're back to 0. 3 of pi over 2, if we negate that, -3 pi over 2, recall negative just moves the other direction, so -3 pi over 2 moves that far, and the sine of that is +1, and then we need to make it negative, so that's going to drop down here. And 2 pi, you make that negative, so you rotate a full -2 pi, we're back to here, the sine is 0, negate the 0 is back to 0. So this one's kind of interesting, in that by putting a negative inside and a negative outside, we basically flipped it this way and flipped it that way, and both of those have made it so we're back to our original function, our original curve. So this thing will continue like that. So that's question 8. And we can see that in the answer that what we've done matches. Now let's look at question 12. We're graphing the cosine function. We'll do the same thing. We'll pick some values, plug them in. We know that this 2 out in front is going to give us a vertical stretch. The negative is going to reflect about the x-axis. Those are our transformations, but the reality is we can pick some values and see what we get. If we plug in 0, the cosine of 0 is 1. 1 times -2 is -2. We could plug in pi halves. Cosine of pi halves is 0 times -2 is 0. Plug in pi. The cosine of pi is -1 times -2 is a +2. Plug in 3 pi halves. The cosine of that is 0 times -2 is 0. Plug in 2 pi. The cosine of 2 pi is 1 times -2 is -2. So we can see that this is not unlike our other curves. We would again have some symmetry here because it is a periodic function. So that will give us our graph, and that matches pretty well with what they have on the answer key. So picking some values is sometimes the best way to graph these functions. like that. I hope this helps.